Do any of you guys follow the stock market at all? Today, Zoom stock went up like crazy. Everyone in the world is using it, I guess. Okay, and we'll actually, when we do percents and stuff, we'll do some stuff with stocks a little bit, which I think is fun. Okay, so here's the diagnostic. So I wanted to first talk about question one. And the first thing is being aware of like things like this. So what's the difference? Are these equal to each other? Anyone want to volunteer to share what they think about this and why this is a really common trap for a lot of students? Amy, yeah, go ahead.
So on the first one, the power of 3 goes to the 2 and the x.
Mm-hmm.
But on the second one, it's only attached to the x.
Exactly. Nice. Perfect. Thank you. So this is, whatever something's in parentheses, the parentheses always is more important in PEMDAS. The parentheses comes first, then the exponent. So one way you should really think about this is 2x to the third power, so it's 3 copies of 2x. So this is really equal to 2 to the third, because you can reorder them, times x to the third. So this is really 8 x to the third. And this one is just 2 times x to the third. So these are not equal. Excellent. So this is a really common trap, and it also shows up a lot when there's a minus sign. So this is something to be careful with. How about this? What's the difference between minus x to the fourth versus minus x to the fourth? And can anyone explain kind of, are they equal, why or why not?
Those two aren't equal mainly because since you're pretty much taking on the one on the right, the ones that are in parentheses, so it's negative x to the fourth, that will eventually turn to a positive positive x to the fourth. While
Nice.
On the other hand, you're kind of you have the negative, so it's technically -1 times x to the fourth.
Nice. Exactly. And what's the rule? Why does PEMDAS apply here? What part of PEMDAS applies here? It's kind of sneaky. It's like a little...
Because you do parentheses first, you technically are anything inside the parenthesis that is according to the exponent, that's what you multiply. Since the one on the left that doesn't have the parentheses, you do exponent first before multiplying the -1 in.
Exactly. Awesome. Nice. Thank you, Warren. Yeah, the minus sign is like secretly multiplying by -1. So just keep that in mind, that it's actually the same rule as what we just did example in the first example. And that's something that I still can make a mistake doing this. So just be careful whenever you have minus signs and powers that you distinguish between the negative of an exponent or the negative of like some term raised to a power versus a negative quantity raised to some exponent. So this comes out to, when you have this comes out to x to the fourth, and the first one is negative x to the fourth. Okay, very good. And then the other thing is, we sort of talked about it a little bit yesterday. We showed it with numbers, but how do you interpret something like this? What do you do if you see something like 2 to the negative fifth. What do you do with the negative exponent? What's the simple rule? If you see a negative exponent, what should you do? And based on what we saw yesterday.
Oh, you put a 1 on top, so you make it a fraction, so then it's 2 to the fifth over 1. I mean, under
Awesome.
1.
Yeah, perfect, right. You think of this as, rather than being 2 to the fifth, you're dividing by 2 to the fifth. So it's like you're multiplying by 1 over 2 to the fifth. And if you remember that table that we had yesterday, like we were doing powers of 4, and we said how 4 to the negative 1 would be 1/4. And if you keep dividing by 4, it's like you're repeatedly multiplying by 1/4, or here we're repeatedly multiplying by 1/2. Very good. So negative exponent kind of means just take a reciprocal, or one sort of rule that's handy for these manipulations. Once you're comfortable with like what the meaning is, you can use the rule that I think many of you have seen. When you see a negative exponent, especially in an algebraic expression, you can bring things downstairs and bring things upstairs. So negative exponent makes things move across the the bar there. That's kind of a way you can think of it, just as a rule to manipulate these expressions. And so that turns into that. And then how about this? What if we see something like this? Just to think about this. What about 1 over 3 to the negative 1? What would this be?
Would it flip as well?
Yeah. Well, what was that, Archer?
Would it flip as well? So it would become 3 over just 3?
Exactly. And I'll just do one like kind of step that you can just think of it just flipping, but just so that you see it, we just explained why 3 to the negative 1 is 1/3. So this is just 1 over 1/3. And now you think, wait, how many times does a third go into 1? Oh, it goes in 3 times. So this is really just 3 over 1. So using these rules, that negative exponents flip things across a division, or like a bar, and being super careful with parentheses, these rules are all you need to know to master question 1. And believe it or not, the question 1 I find, like, for my students, and I think you guys will unfortunately find this too, is the one that most students struggle with. For like, you get the concept, but it's still somehow always tricky to apply. Like even a few months in, I have students that when I give them that question again, will make mistakes. So it's a really good question, I think, to master. And if you get strong at these questions, it's very, very useful for future math classes. So now let's try question 8 together. So let me just copy and paste it. All right. Okay. So we have here 4x to the minus 3 all over 2x to the negative 1. And one thing to keep in mind, when you do this method of just moving something across from the basement to the first floor or whatever, move them across the level. If you move something and there's nothing left over there, there's just the 1 that remains. That's an important thing that just to keep in mind. So how can we think about this? Well, the 4x to the minus 3, there's no parentheses here, so this is really 4 times x to the minus 3. And you can just do this step by step. The x to the minus 3, that tells us that x cubed has to go into the denominator. So we have 4 x to the third. And the 2x to the minus 1 tells us that the entire 2x needs to be moved to the numerator. So this just becomes 2x. And I took the entire 2x. If there wasn't a parentheses, the 2 would have stayed in the denominator, but the and only the x would have moved up. And now you can try to simplify. This becomes 8x all over x to the third. And I believe the question said to use positive exponents, so we're not going to move it back to the numerator. We're just going to keep it as 8 all over, because the x's will cancel, x squared. Are there any questions on this example? And I was really happy that several students in the diagnostic that you guys uploaded made a mistake on this. So I hope that this example is good practice. Okay. And then let's try B, and then I'll give you guys 2 examples. I'll just come up with 2 examples that you can practice on your own. But let's try B together. And if you're already comfortable, go for it on your own as well. So B was what? I'm just going to copy and paste here. Oh, I didn't need to write that. Okay. So B looks a lot more complicated, but in reality, whenever I see complicated expressions in math, I always just try to use the parentheses to tell myself, you know what, whatever's in there, I can worry about how complicated it is later, but let me just worry about things outside of the parentheses, manipulate that first, and then simplify to whatever's inside the parentheses and deal with it. So the first approach here I would take is, well, I see that I have xy to the third in the denominator, and it's a positive exponent, so that's not going to change. That's going to stay as xy in parentheses to the third. But the numerator is interesting. It's got that -2 exponent, so maybe I can just bring that whole expression, like if it was, if this was just a simple expression, you just bring it down and square it in the denominator. So I'm going to bring it down. When I remove an entire expression, I'm left with a 1. It's, because I'm taking the reciprocal of it. So I'm left with a 1, and in the denominator, I'm going to have -3 x cubed y squared. But it's all now no longer -2, but it's all squared. Any questions? Oh, sorry. Somebody. By the way, if you ever, make sure you have like a buddy or 2 in the class, and I encourage you guys to make a group where you can all chat. But because I have it set up for, I have to admit students, if you're ever late, you can text a classmate and they'll just like speak up, say, hey, make sure you let someone in, because I might not see it if you're a little bit late. Or sometimes also Zoom cancels and then you have to get back in the room or whatever. So, so a few questions here. Ivan asked, where did 1 come from? Oh, okay. So where does the 1 come from? So this 1, like the reason that we have it is a very good question. If I have 5 to the -2, what it really means is rather than multiply by 25, it means the same. It tells you the same operation as divide by 25. Ivan, does that answer your question a little bit? Okay, cool. And so, like, you can break up all these this complicated expression into several different fractions, and you can manipulate each one using them. But here we just did it in one step. Lily, I didn't understand your question there. Would I move the whole expression down first rather than later? Oh, Anaya, we will use the distributor property in a second. So this is not the only way to do this sort of simplification. There are other ways as well. You could instead square, like find out what the numerator is and then flip it over. There's different approaches as well. But this is just the way that I like so that it helps me keep track of what's going on. Okay. And if I ever don't reply to your question, just just speak up during the class too, or keep messaging. Keep if I miss a comment. Okay, Hannah, very good question. So the 2 becomes positive. That's a really important idea because of this. So 5 to the negative 2, anything to a negative exponent, what it really means is rather than because 5 squared means 25. But a negative exponent means 1 over 5 squared. So you can rewrite a negative exponent as the reciprocal of a positive exponent. And vice versa, 1 over 5 to the negative 2. If you think about what this means, given that we already figured what this is just going to be 5 squared. This is really equal to 1 divided by 1 over 25, which is equal to 25. Okay, very good. I really like those questions. All right. So now let's get to simplifying. I'm going to erase these here. Okay, now we're going to simplify here, and we're going to remember that when we see something in parentheses with raised to a power, you could use a distributive law. It's not really, it's like the distributive law of exponents onto products. But I personally just like to really visualize, maybe not actually write it out, but visualize the thing in parentheses being multiplied by itself that number of times. And that reminds me what I have to do rather than just memorizing some law. So for example, I'm actually visualizing in my head when I see this, 1, and I'm gonna write it down here, but I don't actually write it down when I do my work. But I'm visualizing in my head, I see this, xy, xy, and then I see also negative 3 x to the third, y squared, times negative 3 x to the third, y squared. And once I see that, and I know how multiplication works when I have a bunch of things all multiplied by each other, and I know what an exponent means, I have copies of a certain letter repeatedly multiplied by each other, I can just kind of look at everything and say, okay, how many x's do I have? Oh, this will be x to the third, y to the third. So this is the same as 1 over x to the third times y to the third. Then I have a negative 3 and negative 3 squared. That's going to be times 9. And then what's the exponent of x to the third times x to the third? How many x's in total are being multiplied by each other? And you guys can message me here. X to the third times x to the third, what exponent should we have? Nice, okay, good. A few people say 6, a few people say 9. Do you see why, those of you who said 9, do you see why it should be x to the 6th? Because it's x to the third times x to the third. This is really like x times x times x times x times x times x. So when you multiply 2 different powers, you add the exponents. The reason you might multiply exponents is when you have x to the squared, an exponent raised to an exponent, then it's going to be x to the 10th. And we'll work more on this later as well, but that's just a kind of because you have x squared written 5 times. And then if you count how many x's you have overall, you'll have 10 x's multiplied each other. So this becomes x to the 6 And you know what? For y squared times y squared, it turns out that either way you do it will give you the right answer, but you want to be adding the 2 and the 2 together because you have 2 y's and another 2 y's multiplied. It means altogether you have 4 y's being multiplied by each other. Okay. Any questions? Give me a yes if you're, so far you're comfortable with what we did. And hit no if, and give me a comment if you have any points where you need some clarification. X to the third is being put to the power of 2. Yes. X to the third is being raised to the second power. Sorry. Maybe those of you who said 9, the final answer will actually have this 9 because of this guy. So, okay. Now putting everything together. Again, we're multiplying through here, so we can just think of this as there's 3 x's here, 6 x's here. So altogether, if I'm multiplying those 2 expressions, I'm going to have a total of 9 x's. And I'm going to have a total of 7 factors of y. So this will be 1 over 9 times x to the 9th times y to the 7th. All right? Oh, no worries. Okay. Great job. So now let me give you guys a chance to work on some of these on your own. So I'm going to come up with an in-class example. So please simplify using positive exponents. Let's say here, 3x to the third no. So 3x to the third all over 3x to the minus 3 all over. Okay, so this is question A. So try this one out. And for B, we'll do one that's a little bit different. Okay, so please write these 2 questions down. And I'm going to maybe give you guys a few minutes to work on this. And message me when you're done and what you got for part A and B. And I'm going to do these on a little piece of paper myself. And also try to do this without any calculator. So simplify as just like a fraction and only having positive exponents. Okay, so what I'm going to do now, actually, because I'm seeing some answers, I'm really curious how you guys are getting some of them. And what I'm going to do is I want to make some breakout rooms. Does everyone have these problems written down? Okay. If you wrote an answer to me and I didn't get back to you, so I'm just going to create some breakout rooms, maybe with like 8 people in a room or so. And then I just want to see like if you guys can share some of what your work was, so we can kind of go through and I can spot. I'm interested to see where people went wrong on some of these. So I'm just going to do it really quickly here. Breakout rooms. I'm going to assign participants into, let's say, yeah, 6 rooms. Yeah, let's just try this. Oh, and in the breakout room, just feel free to unmute yourself, talk with each other, compare your answers. Some students got them right and some didn't. So just have a discussion. I want everyone in the room to say, okay, now I got what to do. And you can also share the screens as well. Okay, guys, welcome back. So I was really happy to see that many students, I think some students are still coming back. Whoa, let's see. Okay, welcome back, everyone. Thank you guys for sharing your work in your groups and also helping each other out. I was really happy to see that you guys discussed your ideas and helped catch each other's mistakes. Here I wrote the solution for part A, and hopefully you guys were able to get that in your group. And for part B, it's similar to what we did before. And again, I'm going to always post these notes on the Google Classroom, so if you ever miss something, you can still access it from Google Classroom. This would just be move the y to the numerator because it's just by itself, so y to the third. And then the denominator, we still have 2x squared, but now we have 4xy squared. And then this just becomes, when you multiply all this out, you get y to the third, and then 2x squared times 16x squared y squared. And if you simplify the last step there, you'll get y to the third all over 32 x to the fourth y squared, and the y's cancel, leaving you with y over 32 x to the fourth. Okay, any questions on these two examples? Okay, let's move on to the next. We got like about maybe a half hour or so, so let's do a little bit more. So yeah, part two, I won't really go over that one too much. Just be careful with 2b. Don't use a calculator for these either. For 2b, a lot of people, if you haven't, especially if you haven't worked with decimals in a while or subtracted numbers, a lot of people get confused with 2b. Well, I'll just write these here. Yeah, for 2a, you know, you write p equals 4/3 plus 1/6. Message me in chat. What's the main thing we need to do to combine fractions here? Or you can just blurt it out too.
Common multiples.
Yeah, common denominator, common multiple. So we get, this will be, to make it a common denominator, you have to make this one a 6. So this would be the same as 8 over 6 plus 1 over 6. And so this is just going to be 9/6. And here, just being careful, 1.4 minus 4.3. And you guys will hear me say this a lot. I also hate decimals. So do you know what my trick is for working with decimals? Just get rid of them. What's 14 minus 43? They are 14 minus 43. How far apart are they? They're going to be 29 units apart. So 14 minus 43 is negative 29. But we're talking about 1.4 minus 4.3. So this is really just negative 2.9. And so this is a type of calculation that I would hope that you could do eventually just comfortably mental math without a calculator, without even writing anything extra down. I know it can get you into trouble, it could lead to some mistakes, but I think it's a very good thing, very good skill to develop. Okay, let's take a look at number 3. If we could do 3, 4, 5, 6, I think that would be a good goal. Or maybe, yeah, let's. So I'm just going to go over number 3. And all of these, by the way, are in parts of the review, so I think everything is kind of everything is covered in the different review sections. So with inequalities, you can treat them like algebra. Does anyone remember the one thing about inequalities that you have to be really, really careful with? There's one thing of inequalities you have to be very careful with.
Like when you flip it, when you divide by a negative? Exactly,
very good. So when you multiply or divide by a negative, you got to make sure to switch the sign. And that just comes from the fact that, you know, if 3 is less than 4, then that implies that on the negative side, if you compare negative 3 to negative 4, negative 3 will actually be greater than negative 4. And you can even move it around. So multiplying, dividing by a negative sign is the only thing to really be careful with. Otherwise, you can treat it just like a normal equation. So we'll have 3x plus 6 is less than 20 minus 4x. And because I know this fact about like multiplying, dividing by a or multiplying, I always try to avoid, we need to switch, not swith, but switch. We need to switch inequality. Because I know this fact, whenever I'm doing the algebra, I always want to set myself up to avoid mistakes. And I'm very, like, I make a lot of mistakes. So I strategize, what do you think would be better? To subtract 3x from both sides or add 4x to both sides? And it doesn't really matter. It's just you'll get the right answer either way. But I prefer to add 4x and subtract the 6 just because this way I'm not going to end up with a negative x. And then I won't have to worry about flipping things. It doesn't really matter, but just these little things can help you as you're doing algebra. And I'm going to do something. I'm just going to write the next equation. I really don't encourage students to do this. So I think a lot of you have been taught that this is the good way to write it, 4x. So then you get 20 is less than 6 plus 7x. If you feel very uncomfortable skipping this step, then keep doing it. I don't want to kind of push you too much out of your comfort zone, but what I encourage you to do is just don't do this. You can try to just visualize, okay, I'm going to add 4x to both sides and subtract the 6 from the other side. And when I do that, you can almost get there in one step. You can just write 7x is less than 14. And maybe like you don't have to jump like 3 steps ahead, but if you can save yourself that plus 4x minus 6 minus 6, I think it's I think you'll be able to stay in the flow of solving the problem rather than get caught up in the little steps like that. So if you can kind of see things a few steps ahead in your mind, it's a very good thing. And a lot of people tell me when I suggest this, like, oh, Mr. Ritz, I'm very visual. I need to actually see the steps. And it's true. It's good to see the steps, but just see them without writing them down. Try to visualize them in your mind. And then the last step here, if 7x is less than 14, we want to divide both sides by 7. So we get x is less than 2. Archer asks a very good question here. So we can skip around without showing that type of work. Exactly. I'm not even okay with it. I actually want to encourage you to do this type of skipping the algebra steps like this. You'll see later that I'm very, very, not strict, but like, I'm a very strong advocate of actually writing down your work very, very carefully and explaining what your ideas are, especially when it comes to word problems, like defining what the variables mean, almost like being like a lawyer. Like, if you ever look at legal documents, they're like very, very specific about what they talk about. Like the person in this document, the leaser of this property, henceforth, whatever. They're very, very specific. So I encourage that type of work. But these 3 steps would be completely fine, and this is actually what I want to see. And I think for some students this is a little bit uncomfortable because it's not the way that you're used to doing it. And it just takes, just like mental math, it's a skill that takes time. It could get you into some mistakes, but as you get good at it, you'll be able to see a few steps ahead, and you just kind of be writing out the basic equations, and you'll kind of even know, you'll know what to expect, so you'll be able to catch your mistakes easier. Okay, and then set builder notation. We're going to do a bunch of stuff with inequalities, but set builder is we write a set with these kind of curly braces. We write the variable x, and we say such that x is less than 2. This is set builder. This is this bar means such that, and this is the this is the condition that we want our variable to satisfy. This is a variable. There's also, I'm sure you guys know, there's also, what do you call it, interval notation, which we'll spend some time on as well. That's the thing where you can write, and then there's a number line. So number line, you have your number line, just sketch where 2 is, and if you guys remember, because it's strictly less than, we want to open circle, and we go down. We highlight that. Interval notation is if you have an interval, you can describe it kind of like a coordinate, where the interval, the first number in the interval is the left one, and the upper bound of the interval is the right number. In this case, it would be negative infinity, comma, 2. So these are 3 ways of expressing the same exact step. Does anyone remember why we use a parentheses here versus a bracket?
The bracket means that the number that is with it is included. So if we had a bracket 2, that means any 2 and everything less than it is actually included.
Awesome, thank you, Warren. So the way I remember that, sometimes if it was x is less than or equal to 2, then we would put this negative infinity, comma 2 with a bracket, and we call this a closed ended, or a closed interval, or partly closed, it's half closed. Versus open. And the way I think of it, what helps me memorize it is just the bracket kind of looks like a door. And you know when you sometimes close the door too fast, something, you know, you can get a finger stuck in there or something like that, or you get a foot stuck in there. So I always just memorize it as when you close the door, that number that you closed the door on got stuck, and it got stuck in there. So the closed interval will actually include the number in the actual number in your interval. So it'll be like less than or equal to. And when you have an interval that goes off to infinity, you can't close the door on infinity. So infinity is always either negative infinity or positive infinity. Will always have an open door, an open parentheses on it. So this is closed versus open ends of an interval. Okay, any questions on number 3? All right, let's move on to number 4. A little aggressive there with the zoom. Okay. So this is the type of problem where you can skip maybe some algebra steps, but I really want to see your setup. And I'll only give you full credit if you actually draw a little picture and describe what your idea is. So in this case, we have a perimeter of a rectangle. Before we start trying to kind of turn every sentence into an equation, it could be helpful, especially if it involves some geometry, to write down, draw a little picture. So yeah, let's draw a picture here with a little rectangle, and we have height and width. There we go. So here's the height, and here's the width. Okay. So now, once I have my picture drawn, let me see if I can apply each sentence to give myself an equation. And you might remember this from word problems, and if you haven't seen it, it's the key to any SAT problem or any word problem you ever face. Do you guys know what the most important word in any word problem is? You can message me what you think, in your opinion, what's the most important. Obviously, this is a kind of open-ended. All of it is pretty important, but there's one that you should always kind of zero in on. I think it's the most important. And we're going to do a whole bunch on word problems as well. It's a two-letter word, and it's not of. Any other? No, it's not no. This is just one word. I think this is the most important word in word problems. Sometimes there's a synonym for it. Not so far. Not centimeters. Not so nice. Archer, you got it. It's is. Is. And do you know why is the most important? In could also be important, but for me, is the most important. Why is the most important? It does tell you what you know, but in a lot of these word problems, it's not actually nice, because it means equal. Yes, there is no leniency in is. It has to be what it is. But yeah, is helps me translate a sentence and focus my mind on where the equal sign is. Sometimes in English we'll see phrases like Mark scored 5 less points than Robert. You have to kind of parse and think about what that actually means in terms of an equation, and you actually end up doing Robert minus 5 equals Mark, or Mark equals Robert minus 5. You have to just take a moment to interpret how to set that up. But with is, whatever is to the left of is on one side, whatever is to the right of is on the other side. And this example is really simple, but we'll see more complicated examples where focusing on the word is or equals can really help you kind of, I guess, get centered literally, because your equal sign is like the center of the equation. Okay, so the perimeter of a rectangle is 32. What's a good expression for the perimeter of a rectangle? If we know the height and width, how do we find the perimeter? In terms of h and w, what would be a good expression?
What I used was 2h plus 2w, so
Perfect.
that covers each side of the rectangle.
Nice. That's something to be careful with, especially with perimeter, because we know area is h times w, but perimeter is height plus width. Thanks. Nice one. And then the second one. This is where our English can fool us. What do you write for the second equation? And message me in the chat. What do you think? Oh, go ahead. Yes.
Oh, I wrote w equals h minus 2.
Excellent. And do you know what a lot of students write here sometimes? I think that maybe like 50 or 40% of students, if they're rushing, they'll write something else. What do you think that they write?
Maybe the other way around, like h equals w minus 2.
That could be. I find that, especially if you're just reading and then trying to write things in that order, you see less than, you think that's subtraction. So a lot of students will write w equals 2 minus h. And then that'll make all the math get really confusing. And that's just an unfortunate thing of how we talk in English versus how we write things in math. So if you say 2 more than the height, then you can write w equals 2 plus h, no problem. But when you say 2 less than, it means you take your the quantity that you said less than, and you subtract the thing that you first talked about. is just a quirk in the English language about how we talk about subtraction. So just being aware of that and knowing that mistake can can prepare you if you ever see that sort of trap on a test. I wouldn't even say it's a trap, but it's just like if you see a lot of those types of statements, a lot of people get really intimidated, and understandably, it can be very confusing if you have to parse these. Okay, any questions on why we wrote W equals H minus 2? Okay, last step, we'll now that we know the width is height minus 2, we have two equations with two unknowns. We can just do a simple substitution. Instead of this W, let's just replace it with H minus 2. And we'll put it in, instead of here, we'll put it right here. So we'll write 2H plus 2 times H minus 2 equals 32. Whenever I do a substitution, these are the kind of the steps that I really think are important to write out. So I'm not skipping any steps here. I'm carefully writing everything that I'm substituting. Now I'm going to expand, and I'm still going to write everything out. So I'll write 2H plus 2H minus 4 equals 32. And now I'm combining the two H's. I'll move the 4 to the other side. So I have 4H equals 36, or in other words, H is equal to 9. And if H equals 9, it's also good to remember that W equals 7. Okay. And this is an important step, especially when you solve these sort of problems with two unknowns. I'm not going to be super strict about it, but on a SAT or a multiple choice test, always double check which unknown answer you need to give. Because I'm sure that if it was a multiple choice, that they would try to have a trap for you saying, oh, is the height 9 or is the height 7? And if you solve for the width, you might jump, oh, I got 7, and then you might put that incorrect answer. Always confirm what is asked. Okay, very good. Any questions? Alice, a good question. I don't care too much about units unless we're doing something specific about like converting to different units. But yeah, in physics class and chemistry, you do have to be careful with units. So maybe it's a bad habit, but don't worry about units that much in this class. All right, let's try number 5, and then maybe 6, 7, and 8 we can cover tomorrow. And again, each of these like examples is could be its own lesson in an algebra intro to algebra course. Oh, we don't have class tomorrow. Thank you. The next class, Thursday. No class tomorrow. Classes are only Monday, Tuesday, and Thursday. All right, let's try number 4. Okay. So we might end up spending a little more time on equations of lines. It is definitely a prerequisite for the course, and it's something that I expect you to be able to do very well. But it's also a skill that's like probably the most like fundamental skill for understanding like what calculus is about, and also moving on to multivariable. It's like the equation of a line is a very useful and simple concept, and it's incredible how fundamental it is to more advanced math as well. The first thing I like to do with equation of a line is we could just jump into the formula and just do it as is, but it's important for me, especially like because I'm scared of minus signs and subtracting things and getting things mixed up. I always want to do a quick little sketch. It doesn't have to be like I don't actually need to do all the grid lines, but I just kind of want to get a vague sense of where the points are and what to expect with the line, what it should look like. So -4, 3 will be somewhere up here. So this will be -4, 3. And -2, 6 is going to be up here. Where I should be careful, this is my x-axis and this is my y-axis. Any questions on plotting the points? Okay. Sorry guys, I'm just gonna, I'll be right back. I have some call here. I'll be right back in. Sorry about that. All right. So what we know from this is, or does anyone want to kind of tell me if it's y equals mx plus b, what we can expect for m and b? Before we do any calculation, what should we expect? And what do they stand for?
M's going to be positive.
Nice. M is the slope, and it's positive. And how about the b?
It's probably also going to be positive.
Nice. It's the y-intercept, and it looks like if we draw the line, oh, that's not what I want to do. It looks like it's also going to be positive. So that's kind of some intuition we can have just from drawing the picture. Okay, so now to actually get the slope, if you guys remember, to calculate the slope, what you want to calculate is the rise over run. So m equals the rise over the run. And if you recall, there's a formula for it. You can take the second point, the height of the second point, subtract the first point, divided by the run or the x-coordinate of the second point minus that. Or alternatively, you can also look at the picture and you can draw a little triangle. This way you kind of remember this formula for life. So what's the change in height if you go from the first point to the second point? How far apart are they? How long is the green line segment? How far apart is the green line segment? Nice, good. So the green line segment has a distance of 3. Oops. I want to use this color. This is 3. And the red line segment, from -4 to -2, they're positive 2 units apart. And I always like to keep personally, I like to go from the left point to the right point, no matter what order I'm giving them in. And I think of the slope as being negative when I'm going, as I move from left to right, as I drop down. So if it was, instead of being 6, if my y-coordinate for the second point that I was given was like -2, 1, then I would see that I would have a negative slope, and that height would be negative. So yeah, you can also alternatively just plug it into that formula. So when you do that, you get the same result. You get this is equal to 6 minus 3 all over -2 minus -4, which is just going to be 3 over 2. So now that we know the slope, the next idea, there's 2 approaches to doing it, and I'm going to show you something called point slope form. One approach, yeah, so there's 2 different approaches. You can use either one, but my favorite is point slope form. So now that you have the slope is 3/2, you can pick either of the points. So pick either point. The idea with slope, and what makes a line, is that if you have any other random point, x, y, the idea is that if you were to draw another triangle using x, y, and one of your points, let's say -4, 3, and you were going to draw in the vertical and horizontal legs, do you guys see what sort of situation we have here with these 2 triangles? How can we describe these 2 triangles if x, y is on the line? What's a good geometric concept to describe those 2 triangles? When you have a triangle within a triangle that looks like that, what's a good, what should that remind you of? Nice, Allison, dilation. Or in other words, similar triangles. It's the same shape, but just dilated. And if you remember, with similar triangles, the whole thing with similar triangles is that corresponding sides have the same ratio. So if you actually look at the purple side, if you think about what that is, that tells you that y minus 3 all over x minus -4 has to be the same, or has to have the same sort of slope or ratio as the other 2 points. And from here, you can get the full equation. So you can write y minus 3 equals to 3/2 times x minus -4. And then this becomes y is equal to, I'll be careful here. I'm not going to jump too much. Y minus 3 equals 3/2 x plus 4, which is the same as 3/2 x plus 6. Add 3 to both sides, I get y equals 3/2 x plus 9. So this is one way you can do it, and this is called, this form of the equation is called point slope form. And I encourage you to think about why this works. And it really has to do with similar triangles. All right, guys, that'll be it for today. Do you have any questions, or does anyone have any questions that they want to ask? No new homework. Just continue working on the diagnostic if you haven't finished it, and the only homework will be from the textbook. So the review sections, and they are on page. Let me see here. And by the way, there's also answers in the back. The review sections are on page, in the appendix, are they? Oh, wait, maybe they're not there. Oh yeah, they are in the back, starting on page 933. And I assigned the homework to be due, I think next Thursday. So, and we'll try to go through, we'll delve into some of these questions in a little more depth. Okay, guys, have a good rest of your day. I'll stick around if anyone has any questions, but otherwise, I'll see you next time. And well done today. Thank you. Oh, the page was, the starting page was 933. See you. Oh, the 3/2 x plus 6, it comes because I distributed the 3/2 across. So the 6 comes from 3/2 times 4. Okay. Oh, you know what? I didn't know that. Let me just see here. Oh, you know what? My bad. Okay. Now, you know what? I need to change that in the beginning of class. I got to figure out how to do that maybe for every class. Emily should now be open to chat with everyone. My bad. That I was wondering why nobody's doing like public messages. So thank you for asking me that. I thought I had it enabled.